Hi, so we're going to be talking about this particular linear programming problem that deals with the farmer, so also known as our farmer problem. I want to read it first because that's always step one of problem solving, especially with word problems. So a farmer can make a profit of $250 for every ton of alfalfa harvested and $350 for every ton of corn harvested. Corn requires 3 hours per ton to harvest, while alfalfa requires 2 hours per ton. Each crop requires 1 hour per ton for planting. The planting time available is 500 hours and the harvesting time available is 1,200 hours. How much of each crop should the farmer grow in order to maximize his profits? So step two is to figure out what you want your variables to be, to define your variables. So that usually comes from the question. So how much of each crop should the farmer grow in order to maximize his profits? Well, what crops are there? There's two crops. There's alfalfa and there's corn. So we're going to let X equal our alfalfa crop, and we're going to let corn equal, or Y equal our corn crop. So our next step is to determine our constraints, which is our inequality statements, along with our objective function. So that comes from the rest of the information that's in the problem. Notice that you typically always have X is greater than or equal to 0 and Y is greater than or equal to 0. This is saying that the least amount of alfalfa that you're going to grow is nothing. And the least amount of corn that you're going to grow is nothing. So you want to make sure that they're greater than those amounts because you want it to be greater than 0 and for each one of those. Each of your constraints end up getting graphed on a coordinate plane. So X being greater than 0 is a vertical line at X equals 0, and Y being greater than 0 is a horizontal line at Y equals 0. So we talked about before that you can test the point 0, 0, but this one isn't a very good one because 0 happens to fall on this line. So you might want to test a different point or know that X is greater than 0, so you would shade to the right. When we're talking about Y being greater than 0, you would shade above. We have our other constraints that come from the rest of the problem. So it says that corn requires 3 hours per ton to harvest, while alfalfa requires 2 hours per ton. And because we're talking about harvesting, it tells us that our harvesting time available is 1,200 hours. So that's 2 hours for every alfalfa and 3 hours for every corn. And we have a maximum of 1,200 hours. So that 1,200 hours has to be greater than or equal to our amount. Our farmers can't go more than 1,200 hours as far as their harvesting goes. They can only put at most that much in. And for planting it, it says that they have a planting time available for 500 hours. So each crop requires 1 hour per ton for planting. So this would be 1 hour per ton of alfalfa, 1 hour per ton of corn. Has to be less than or equal to 500 hours for the planting. So when you're graphing these functions, we take them from standard form and we change them into slope-intercept form. So you're graphing Y is less than or equal to negative X plus 500. That's your Y-intercept at 500, and you're going down 1 over 1, down 1 over 1, down 1 over 1. So you have that line there. When you talk about Y is less than negative 2/3 X plus 400, you start at 400. You would go down 2 over 3, down 2 over 3, until you have this line with those intersection points. Your objective function isn't graphed. Your objective function we'll worry about in a moment. But this tells our maximum profit in this case. Sometimes it could be your minimum amount. But our first line, a farmer can make a profit of $250 for every alfalfa harvested and $350 for every ton of corn harvested, which is why we usually deal with money when we talk about profit. So in order to obtain the profit, we have to really focus on our corner points. So our corner points are where your overlapping shaded region meets all of them. In this case, we have corner points at 0, 400, at 0, 0, at 500, 0, and at 300, 200. So each of those values are now going to be placed into our objective function. So we had 4 corner points. We should have 4 times that we substitute into our objective function. So you substitute in for X and for Y, and you solve, and our point 0, 0 produces 0 profit. That should make sense. If you don't have any corn or alfalfa, you're not going to make any sort of profit. So that produces 0. If I have 0 tons of alfalfa but 400 tons of corn, again, you're substituting in, I should make $140,000. Similarly, that you would do the same for each of these. You will notice that one of them is higher than another. So that happens to be your maximum profit. which is the point 300, 200. Once you figure out your maximum profit, you want to make sure that your last step should be that you write it in a sentence. So in order to maximize the profit, 300 tons of alfalfa, which is represented by my X, and 200 tons of corn, which is represented by my Y, should be harvested.